stuff that you have to deal with in this chapter, this school year. When you're dealing with section 14.3, we're talking about what's called verifying and simplifying trigonometric identities. When we have trig identities, you guys already know like the inverse of sine is cosecant. Cosecant is the inverse of sine. You agree? Secant, inverse of cosine. And cotangent is the inverse of tangent. Well, what we're going to do is we're going to, on that little note sheet that I gave you, is that we're going to talk about properties. Did you guys all get one? Going back? All right. Another way of writing this, and one thing that I wind up doing a lot of times in this section is that I don't normally write x, like cosecant of x, sine of x, thetas. Since you're writing these out so often, it's not a big deal if you don't put an x here or here. I really don't care, to be honest with you. We're not graphing anything in this section. We're not solving equations in this section. We are simplifying and verifying. Basically, it's trigonometric proof. Right? It's trigonometric proof. It's a puzzle. And by leaving out an x here or there, it's no big deal. It doesn't make any difference on the problem. You're still using identity. Now, what I want to do is, these first identities are already on your sheet. What I want you to think of is that if I take 1 over cosine, or excuse me, 1 over cosecant, what is that? Sine. 1 over secant is what? Cosine. And then 1 over cotangent is tangent. What did we also say that tangent was?
Sine over cosine.
Good. Tangent is sine over cosine.
So would cotangent be?
Cotangent would be?
Cosine over sine.
Very good. Those are very simple, pretty straightforward, not a lot of craziness there. You're just using reciprocals and your basic sine, cosines, and tangents. Okay? What becomes to be a little bit newer is on the bottom of your list there. It's what's called your Pythagorean identities. The Pythagorean identities are your sine squared plus cosine squared is 1. And how that works is, if you think about it, if you're placed at theta, if you put theta there, your cosine is your x, your sine is your y. Isn't that the Pythagorean theorem get your radius? That's how that works. That's how all this stuff is built out of.
And the radius and the
Right. That's how this works. Okay, it's built out of the unit circle by showing that theta is a triangle. Now, one of the things I want to also show you real quick here is that it's not always just going to be sine squared plus cosine squared equal 1. It's also going to be that cosine squared equals 1 minus sine squared. Because what did I do? I just moved sine. Which means that sine squared is 1 minus cosine squared. Do you guys see why I don't have that cosine of x? Is it all right that I'm not doing that?
Yeah.
It's just a little bit, I think it's just cleaner to say and to write, that's all. Okay? All we're doing here is we're using what are called Pythagorean identities and just moving and manipulating the equations by solving for each part. Okay? Same thing with the next one. 1 plus tangent squared is secant squared. Another way you see this a lot is tangent squared is secant squared minus 1. You normally don't see 1 equals secant minus, or secant squared minus tangent squared. That's very rare. Okay? And then the last one, I would just say that cotangent squared is what? There you go. One thing I will say is that you really need to know your Pythagorean identities. If you know those basic 3, the manipulation of solving for the other 4 is pretty easy. Just moving things around. Bless you. Because you already know your sines, cosecants, secants, and cosines, and all that. You already know that. That's not going to be as much of an issue. Now, what is all this going to allow you to be able to do? everything. We have to do this.
He's gonna have a video problem.
Cosby.
Oh, I thought that was Morgan Freeman.
Sine of b divided by the tangent of b is
Cosine.
Cosby. Ah, get it.
Cosine. Yeah.
And it's kind of soon to use a Cosby joke, but
Especially in a classroom.
Yeah.
Like 85. Somewhere in that range.
let me show you how this works. They're saying that it's going to equal cosine. Okay? When it tells you what something is going to equal, that means it's a verify problem. Verify problems tend to be a little bit cleaner because you know what the answer should be. Simplifies, you're kind of, you're out on the limb. Basically what you're going to do is you're going to make the left side equal to the right. You want to show how the left goes to the right. Here's how we do it. This is a fraction. Do you guys agree?
Yes.
So I'm going to rewrite it as sine over 1 times 1 over tangent. Are we okay at that?
Yeah.
All I do is just pull it apart. 1 over tangent is another word for what?
Cotangent.
Cotangent. So this is going to equal sine over 1 times cotangent over 1. I'm going to show all of my steps for right now. What's cotangent?
Cotangent is cosine over sine.
So you get sine over 1 times cosine over sine.
Oh, and then they.
And then what drops out?
Cosine.
Oh, you don't.
That's what it needs to do.
Wow.
It's a puzzle. It's crazy. You guys are going to get very mad. You're going to get very upset. You're going to get really annoyed by this. I'm not going to lie. This is a very difficult section. And it's okay.
We didn't imagine
All right.
dealing with Izzy for this.
You guys have seen this for, hold on, give me a second. You guys have, it takes usually 2 to 3 days to get this pretty much down. It's okay. All right.
So we're
What's
just
up?
gonna be.
How much time am I going to spend on this section?
That's a 3 day.
2 to 3 days. Because then we go into the more complex equations that you have to be able to do this to solve.
I just like it's going to like take 2 to 3 days for you to actually start understanding.
No. By the time we start pretty easy and we work our way up to the more complex things. So here, these are what we call simplifies. And notice in the simplifies, there's no equals. They're not telling you what this simplified version is going to look like. Which means you have to figure out, how do I get it to be as simplified as possible? There are very subtle tricks and ideas to look at as you're going through these. For example, in the first one, we have cotangent times secant. What I want to do right away is rewrite that in terms of sines and cosines. Because if you go to rewrite things in terms of sines and cosines, that's when a lot of your fractions start to simplify out. Right? Whereas in the second one, notice how there's something with a plus sign with a square. A lot of times when you see something like this, you're going to start, when you see like a 1 plus something squared, start thinking, or 1 minus something, start thinking about Pythagorean identities. Those are little subtle tricks that you start to look at. How can I resubstitute something else in? So start out with the first one on the left. Cotangent was cosine over sine, right? So we have cosine over sine times 1 over cosine. What do you get?
One of the signs.
Which is
Cosecant.
cosecant. And you're done. So that simplifies out to be cosecant.
Cool. I was
I don't know why you would assume that Izzy would have an issue with this.
She was probably going crazy.
No, not Izzy. Sine of x times the quantity 1 plus cotangent squared. What would 1 plus cotangent squared stand for?
Oh, that's
So you get sine of x, or so it's sine times cosecant squared?
yeah.
Okay.
Wait, how'd you get that? Yeah, because
1 plus cotangent squared is cosecant squared.
Oh, it's on this thing, okay.
I'm gonna have to
gotcha.
learn
Oh,
those.
yeah.
Yeah, you're gonna have to learn those. Cosecant squared is the inverse of what trig function?
Sine.
So that's the same thing as saying sine times 1 over sine squared. Then what happens?
You get 1 over sine and it's cosecant.
Right. The sine drops out to the second one. You play the game of war. All that thing again. So 1 over sine is otherwise known as? Bless you. And don't worry, not every answer is going to equal cosecant.
Oh, they make it so easy.
Yeah.
Is it gonna equal some, is every answer gonna equal some kind of simple trig function, like whether it be
I don't know.
sine, cosine?
You don't want to
Or will it be plus 1?
We'll get there. Yes, ma'am. No, it's just dumb luck that those are the first two that I had. All right. We're not doing double angle.
Made it so nice. I'm so confused on the very first. Sounds like
Now we're back to our normal.
Secant squared minus tangent squared.
That made the last.
Now, when I see something like this, I've got squared terms, and I have a subtraction symbol, but I don't have anything with a 1 in it. So what I'm going to do is that I probably won't be using some Pythagorean identity here because there's nothing with a 1. But can't I rewrite secant squared and tangent squared in terms of sines and cosines?
Yes.
All right.
Sure.
Secant squared is what?
Wait, but I have a question.
Yes, ma'am.
On this little sheet, wouldn't secant squared minus tangent squared equal 1?
On your sheet, but let's see if it works.
Wait, doesn't that just equal 1?
I don't know.
Is there an equal sign?
It's just,
we're
it's
at
He's enjoying this. If this doesn't equal 1, I'm going to be really upset.
It is.
What?
How'd you do that?
Because tangent is.
Tangent is sine over cosine.
Because you're trying to.
So you score both, you score all
I
three.
still don't understand that.
It's on the sheet.
Yes, ma'am. I don't know. Sweet. Do they have a common denominator?
Yes.
Cosine?
So this is 1 minus sine squared
Or cosine squared?
over cosine squared.
I got it. Just
Also,
What's 1 minus cosine squared, or 1 minus sine squared?
sine squared.
cosine squared. Cosine squared over cosine squared is 1. Can you just
She's
like...
catching up, she's catching up.
Which, if you noticed at the very beginning, that equals 1.
I didn't have to do any of that work.
No, but is it okay if you recognized it that it equals 1 and you just wrote down 1?
Yeah.
I
That's the
mean, like,
whole
if you had
thing.
to work, that was
And
like the
guys-
start of a problem, and
And
you'd
it's
like it's on
okay.
some other stuff, you would
It's-
just write one.
And the reason that I wrote it out in long form there is to show you that a lot of times when you have subtraction things, you're going to work towards getting common denominators. Okay? If you have two terms that are, if you don't know what to do, rewrite them in terms of sines and cosines if you can. Try and combine like terms, go through that. All I'm saying is that it will work. When you're doing these simplifying or verifying, there are multiple ways to show it. There's bunches of ways. Okay? It just takes a little bit of getting used to. If you guys recognize that what is it, 1 plus tangent squared is secant squared, and you use Pythagorean identity, you can use it, go for it. It's done. You got done quicker than somebody else. It's not a big deal. Okay? It's not a big deal.
Yes, sir.
Verify.
We use too much paper.
Again, what a verified is, you're starting with a bunch of stuff. You need to show how it equals the other side. So in this one, I'm going to say that we have tangent times cosecant times cosine, and I want to prove that it equals 1.
So we just need to have like something equals that.
Yeah. Yes, ma'am.
Are we ever gonna have it where like X is a number, or is that like after?
As long as these three x's are the same, all these properties hold. So if this is 30 degrees, 30 degrees, and 30 degrees, it still would equal 1. Because it's the same value of theta, the same value of x. Okay? But we're not going to have to worry about that. We might have some of these identities. We'll have some of these identities thrown into equations, like we did in 14.4, after we go through all this. So we're looping around and doing things really out of sequence, which is fine. This is more fun this way. So I'm going to rewrite everything in terms of sines and cosines. Sine, cosine, 1 over sine times cosine over 1. And that's the kind of work that you show.
Oh, coaster,
What's that?
It's like chemistry.
This is nothing like
It's crossing stuff out.
Wow.
Chemistry.
Dimensional analysis. All right. Well, yes, sir. Cotangent squared over cosecant. I want to show that it equals cosecant minus sine. Okay? Now, we're going to make the left side look like the right.
So we can't like add or stuff.
Nope. So one of the little tips and tricks, things that you'll start to pick up on, is that notice how the first thing you have is a fraction, but your answer is written in terms of with the subtraction sign. So you go from a singular term to 2. That usually means you needed to use a Pythagorean identity, because within Pythagorean identities you can get subtraction. You can get ones. Okay? So if I'm looking at my sheet for right now, since I haven't memorized it yet, cotangent squared is what?
Cosecant minus 1.
So cotangent squared is cosecant squared minus 1, and this is still, oops, forgot my other C, over cosecant. You guys agree on that?
Yeah.
Right now, our common denominator is cosecant. What I'm going to do is break this into 2 fractions. I'm undoing my common denominator by doing the following. Cosecant squared over cosecant minus 1 over cosecant. Okay, what I did is instead of having the singular denominator, I wrote it as 2 entities, 2 separate fractions. And now, what happens? I play war, this drops to that, and I get...
That drops to that.
I wasn't even spinning it and I dropped it. That's weird. And I get cosecant minus sine. It's verified.
That's crazy.
When did we turn to cotangent squared into cosecant?
Right here.
Oh.
It's one of our identities.
Oh, duh.
I love starting out
Okay. I want sine over 1 minus cosine. Yes, sir.
Is there ever going to be a time where like it doesn't verify and you say not verifiable?
Nope.
I guess that's kind of nice though.
Yeah.
If they say it can be verified, it can be.
All right. Who's saying?
I don't know. Who wrote the book? Who wrote the book of love?
Wait, so Mr. Murphy,
What would be fun?
Yes, sir.
so like say people who write the book saying that it can be verified, but when would we like use this in real life and there's not going to be any person that says it can be verified or not? So like, what are we going to use this?
It's the thought process again. It's problem solving. Okay. Here's another way of getting rid of stuff. One of the things that we've learned so far this year to help simplify fractions or work with fractions is multiplying by conjugates. You did this with imaginary numbers. How would you get rid of the imaginary in the denominator?
2 plus I.
We multiply top and bottom by 2 plus I. Because what you did is you multiplied,
4.
what you did here is you multiplied by a factor of 1. You didn't change anything, you're just shifting the shape of it. Now,
Shifting the shape.
sounds shaky. What do you think the conjugate of 1 plus cosine, or 1? I wonder. Multiply top and bottom by 1 plus cosine. Because what you're doing in the denominator there is you're creating a perfect square, a difference of squares.
Like crazy. So in your denominator, you'll have 1 minus cosine squared.
Perfect. Your denominator then becomes, I'm just going to write it down below here, 1 minus cosine squared.
Which is also.
And the reason that is, if I FOIL that out, I get 1 plus cosine minus cosine minus cosine squared. I'm creating that difference of squares. That's what we did with conjugates. Conjugates create difference of squares.
And then you can switch that to sine squared.
We're getting there. Well, the numerator is still sine 1 plus cosine. You okay at that?
Yes.
1 minus cosine squared is
Sine squared.
sine squared.
Okay, how did you do that so great?
Because I've been working on this for, I don't know. I got 3 years. Write these down.
And once again, can I simplify it?
Yes.
Yeah.
Oh, look at that.
Looky loo.
I tried taking pictures.
And you get 1 plus cosine over sine. And it's verified.
Verified.
It's magical.
Once I tried to get verified.
There is no right or wrong way to start the problem. You're gonna fail a lot of times when you start them.
That's always encouraging.
No one's work is so hard, but it's like pretty tough.
Because of that identity.
True.
What's that?
No.
Oh, nothing.
Nice.
Just talk about math
Debating
and
life.
about math.
you want to do that?
All right. Simplify it.
Oh, simplify.
Simplify it. Yes, ma'am. Oh.
Let's see.
It's horizontal math, that's a no-no. She's so horizontal.
So you have 1 plus, or sorry, secant plus 1 times secant minus 1. If you FOIL that out,
It is foiled out. You gotta.
I'm sorry, if you,
lie out. You have to lie out.
Yeah, if you wrap it up.
no, you would have to FOIL that actually.
What? I always forget that foil's like the same thing.
So if you FOIL that out, you get secant squared minus 1. Do you agree?
Yes.
Okay.
Hang on, don't say it. Don't say it. It's tan squared. Over tan. Yes.
And what do you get?
Tan.
I need a
I don't
tan.
think I've ever wrote out the word tangent.
You really have.
Oh, I didn't.
Maybe in geometry or tangents or circles or
Okay.
Hey, Mr. Murphy, when are we gonna connect, like, when are we, in which math class will we connect, like, this tangent and the tangent? I know it's like the same thing, but what are we gonna connect first?
Well, in the circle, all it is, what they're using is a different term. Tangent is also, it's not just like a ratio size. Tangent is, you touch a circle at exactly 1 spot. That's all that, and it creates the 90-degree angle. It's not, it's kind of like the idea that there are 3 twos in the English language.
Oh, so why would they make?
Okay? It's the same idea, where,
Sometimes we learn what there's,
Just like you can say you're going off on a tangent, which means like.
Oh,
you can say
dang
you're
it,
not
Tom, why
passing
don't you
it.
exactly. I know, it's the same idea, you know what I mean? It's that same basic idea that it's contextual. Ooh, look at me. All right?
I saw that post and then on that page and it's so.
Verify!
Math one.
Okay.
Mr. Murphy, I thought.
Allie?
I want to.
So that was a no.
Say it.
The answer is not yes.
I saw your post on the candidates page with the one you were like,
Go do your homework, yeah.
I hope those girls get. Well, and then I went and looked at it, so it was great.
And there's one of you wearing your eye shamrock candidate shirt.
I think one over signed. My parents ordered me one of those. I don't think we ever.
Supposed to pick them up tonight
Oh, really? Oh.
at Rosette. They got me at Rosette at 6:30.
Oh, okay.
Again,
What happens if it doesn't verify out?
you did something wrong.
Okay. It's. So if they ever give us a verified person, we know that it has to equal that, we can even figure out.
A lot of times in these types of problems, when you guys are going to screw up, and this is very common, working with fractions, you're going to forget that this cosine is in the denominator.
Yes.
And that's probably what you just did. Is that what you were saying earlier?
No.
Okay. Just be careful. Yeah. It's very common. You guys forget what's in the denominator versus numerator. So just be careful with it, okay? Simplify.
I enjoy being in this class.
That's all I want in chemistry. Sometimes this class.
How are you worry me a lot?
I'm fine. Thanks. Nice to be outside.
What's the president's thing? I did leave my room. Oh, I got it.
You got that thing over there?
Nope. Oh, see, this is squared. It was.
I still got one.
Wait, were we verified?
No.
Simplified.
I like this because like there's not like a million games you can have. Like those like 6 words with some other yeah. It's not like
You guys get cosecant?
yes.
Yeah. Yes! Oh my god! Wait, so we shouldn't leave it as 1 over sine?
No, because you can always say, well, 1 over sine is cosecant.
Okay.
Does that make sense? Because you can say that is, but then I guess you can say cosecant is 1 over sine, but usually,
Oh, you just made it 1 over.
You know, simplify it. Simplify. Why do they all equal cosecant?
we did that one.
I don't want to sell
This is a verify. Use an equal sign.
1 minus
We had a good question here. How do you tell if it's a simplify or a verify?
Equal sign.
That's all it is. What?
No, it's okay.
It's a good question.
Why did you sound like you were like addressing her as a
I have my own.
Well,
I don't know. I'm not always, evil with me.
you ever just really not know what you're doing?
So I need to make 2 minus secant squared look like 1 minus tangent squared. Well,
oh wait, because secant squared equals 1 over whatever.
that doesn't, but does that get you anywhere?
I don't know.
Because you have to get common denominators as well. Okay.
No.
All right. Well,
Oh, that's dirty.
I took out a D. What?
does that get you anywhere?
Yeah.
Where?
You can do the 1, but no.
Because now 1
Oh,
minus
one,
secant
you can do
squared.
1 plus
Equals negative tangent.
Wow, guys,
We have
that makes
negative
sense.
No.
Okay.
Oh, never mind.
Okay.
You've thrown
What
a
is a
curveball. A 2 times, so you do,
Oh,
you could pull out a 2?
How? Where? Where? Is there a 2 here?
No.
Okay.
You can, you can say secant is 1, secant squared.
No, it's really not going to go sine cosine out of.
Not down though.
Oh, you always go from left hand.
Wait, it's 2 minus 1 plus tangent squared. Oh, smart.
How'd you do that?
Cosecant squared is 1 plus tangent squared. Why didn't I think of that?
Now, here's what happens. And you're right. If you're not careful here, what do you have to do with that negative? That's where you have to distribute. We have 2 minus 1 minus the tangent. That's how you get 1 minus tangent squared.
What do you do with the 2?
This is 2 minus 1.
Goodbye.
What a
Oh, that's crazy. This is weird.
Oh man, that made me feel great.
And I guess, Alyssa, what you were saying a second ago,
Wait, what was I thinking?
I didn't think of this, but you know what? When you had 1 plus 1 minus the secant squared, you said that this value here was negative tangent.
Yay.
Cool. What?
It would have worked.
Wait, she's
I just try not to, I don't want you guys to work with negative angles. It would have worked.
So I was like writing.
You were right.
Yeah.
I didn't think about, right off the bat, I didn't want to do that because I try to avoid, there's negative angle properties that, and double angle properties that we're not going to worry so much about in this class. I'll let them do that in pre-calc.
I think I'm gonna travel on this.
Is that what you're
Give
gonna
us
do?
something.
Oh, I hate it when you do worksheets.
I love worksheets.
I love worksheets.
You're going to have to do this on a separate sheet. This is the problems.
I love that.
You don't really want to roll. No, I always do. I usually go for that one.
Online hour.
It's like, wow.
Now, what I want you guys to do on this sheet, find it.
Every single problem.
No, not yet.
Negative sign.
We're not quite ready to do all those problems yet.
What, you think?
I'm not saying you can't, but
Yeah, I'm ready.
Oral exercise.
I want you to do the bottom part here. I want you to start with the bottom section there, 1 through 18, where it says the written.
Written exercise.
No, and then I want you to do the verifies at 31 through 34. I just want to start with that. As you can see, there are
30.
plenty, 31 through 34, just for the verified. There are a ton of these problems. Don't lose that sheet, because we'll be using that again tomorrow with more complex stuff. And I've got more and more and more, okay?
Which problems are you on the backside?
31 through 34. Yes, sir.
I still don't understand how you get from that.
Here? All right. We had secant squared. Secant squared, if I just cover that up, is 1 plus tangent squared. So what I did is I just rewrote it in terms of parentheses. Since there is a negative 1 out front here, because I'm subtracting it, I distributed, that's where I got this, and that's where we get that. Okay. You okay then? Do those on a separate sheet, because you got room then.
I have to show you this.
Piece of
So
stuff.
you know how you can take like
Number 1.